Today we're going to talk about section 4.7, the quadratic formula. The objectives are to solve quadratic equations using the quadratic formula and to use the discriminant to determine the number of solutions. So far we've covered two of the three ways to solve quadratic equations. We've looked at factoring and we've also looked at completing the square. Today we're going to look at the third one, the quadratic formula. Before we look at the formula itself, we're going to derive the quadratic formula by using completing the square. This is probably the hardest part about the quadratic formula. Using it is very simple. So the first thing we want to do in deriving the quadratic formula is to get a 1 next to the x squared, where we now have an a. We can't factor an a out of a b, so we do have to divide by a to begin with. And I'm going to move over here. So we have x squared plus b over a times x. The b over a is the number part of it. We're also going to move the c to the other side because we know that that isn't going to be necessary on the left side when we complete the square. So 0 over a is 0, so that doesn't change anything. So to figure out the number that goes in that blank space, we do exactly what we did before. We take half of b over a. It's the same as multiplying by 1/2 or dividing by 2. And we're going to do the same on the other side since we added. I'll write it the same way this time. We know that we have to factor next, and what we have purposely done is come up with a factor that is exactly what we need. So when we factor it, we have two items that are exactly the same. Sign and everything goes in here, so b times 1 is b, 2 times a is 2a, and that'll be squared. On the right side, we're going to simplify a little bit. On the bottom, the 2 gets squared and the a gets squared. And now off to the side, I'm going to put those together. So this right here becomes negative c over a plus, oh, and this should be a b squared back here. I forgot that. So b squared over 4a squared. Now what we're going to do is we need a common denominator, so it's going to be the 4a squared. So the item that the first term is missing is a 4, and it's also missing one of the a's. So when we put those all together, it looks like this. Which then becomes b squared minus 4ac all over 4a squared. The reason that I changed it is because it just looks nicer with that squared ahead of it. And if you look ahead to the formula, that's the order that they want it in. So let's put that in there. X plus b over 2a squared. And we get b squared minus 4ac over 4a squared. To undo the squared, we square root both sides. That gives us a plus or minus on the right. And I'm going to separate these into two different square roots because one of them might be able to be simplified. So the top part cannot be simplified, but the bottom part can. The square root of 4 is 2, and the square root of a squared is a. Then we subtract b over 2a from both sides. And we put the two terms together because the denominators are the same. And that's how you derive the quadratic formula. As you look below, that's exactly what it looks like. So, how do you use the quadratic formula? The first thing you want to check is everything on the left side in descending order? In this one, it isn't. So I'll subtract 4 from both sides. Then the purpose of this is you want to get it into this form, which is standard form. Because then you can see what A is. A is 2. B is -1. The signs and everything go with the numbers. And C is -4. And those three things will go right into the quadratic formula. I'll write it again. So plugging them in, a negative b would be a -1, which is 1. I like to actually square them out before I write them down, especially under the square root, because a lot of people get those signs wrong. So b squared would be a -1 times a -1, which is 1, minus 4 times 2 times -4, which are the values for a and c. And then 2 times a underneath, which is 2 times 2. Then it's kind of all about simplifying. So under the square root, you'll get a 1 plus, since there's 2 negatives, 32. So it'll be the square root of 33 over 4. And then you write the answers separately. So 1 plus the square root of 33 over 4. And the other answer would be 1 minus the square root of 33 over 4. When you're doing this, you want to double check to make sure that that square root or that radical can't be simplified. This one, square root of 33, there's no perfect square factors that go into it, so we are done on this one. The next one maybe won't work out so well. So we look at the order on this one. We have our x squared first, our x second, and our number, which is exactly what we want. Then we determine our a. A is 1, b is 6, c is 9. Plug it into the formula. So we get -b, which is -6, plus or minus. B squared, which is 6 times 6, that's 36, minus 4 times 1 times 9. Over 2 times a, which is 2 times 1. So 36, subtract 36 is 0, and the square root of 0 is 0. And that just means that we're actually simplifying just a -6 over 2. So this one only has one answer, which is -3. So they don't always come out as strange answers. Sometimes you get one answer, sometimes you get no answer, sometimes you get 2 answers. So here's the got it questions that we'll practice. This one again is not all on the left side, so we'll move it. Determine what A, B, and C are. A is 1, B is 4, and C is 4. Plugging it in, -b is a -4, plus or minus, square root. B times b would be 16, or 4 times 4, minus 4 times 1 times 4, and a 2 times 1 on the bottom. 16 subtract 16 gives you the square root of 0 again. So this is one of those, we'll get one answer, which is -4 over 2. Last got it question, it's all in the right order. A is 1, B is 4, C is -3. So -b would be a -4 plus or minus the square root of 4 times 4, which is 16, minus 4 times 1 times -3, and a 2a on the bottom. 16 plus 12 would be the square root of 28 over 2. Now we're going to do a little simplifying. What we want to do is we want to break down 28 into its factors. I look at, does 2 times 2 go in there? Does 4 go in there? Does 3 times 3 or 9 go in there? Does 4 times 4 or 16 go in there? If you possibly can find a perfect square that goes in there, do that. So 28 is 4 times 7. So I'm going to look at square root of 4 times square root of 7. Then we simplify them both. So square root of 4 is 2. Square root of 7 cannot be simplified. And there's a 2 on the bottom. And now our two answers look like this. On this one, I'm noticing that both of these numbers that are outside the radical or the square root can be simplified. So we're going to do that right away. Negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. Our two answers now are negative 2 plus the square root of 7 and negative 2 minus the square root of 7. So it basically gets you working with numbers that are nicer, especially when you end up with answers that are not so nice. Going into the application question. Your school's jazz band is selling CDs as a fundraiser. The total profit, P, depends on the amount X that your band charges for each CD. Excuse me. The equation P equals negative X squared plus 48X minus 300 models the profit of the fundraiser. What's the least amount in dollars you can charge for a CD to make a profit of $200? So the $200 is your P. What we're going to do first is we're going to substitute that in and simplify a little bit. So we put the $200 in for P. We're going to subtract it to the right side. Actually, we're going to bring everything to the left so that that X squared is positive. You can do it either way. It works out in the quadratic. So X squared minus 48X. We're going to add 300, so plus 500 equals 0. If you had it on the other side, it would be a negative X squared, a positive 48X, and a negative 500. And again, the quadratic formula would work either way. Plugging it into the quadratic formula, we get A is 1, B is negative 48, and C is 500. So larger numbers, but it still works. So negative 48 would be 48 plus or minus the square root. 48 squared is 2304 minus 4 times 1 times 500. All over 2 times 1. So let's simplify that radical a little bit. Okay, so 4 times 500 is 2,000. So we're going to end up with the square root of 304. 304 doesn't sound like anything that we can simplify very nicely. But again, this is a word problem in dollars and cents. So what we're going to do is we're going to just take them to each answer and see what we get. So we're going to do 48 plus the square root of 304 on our calculators and then divide it by 2. We're also going to do 48 minus the square root of 304 on our calculators and then divide it by 2 to get our two separate answers. So 48 plus the square root of 304 is 65.4, and then I'm going to divide it by 2. So I get 32.72, and that would be dollars. The other one would be 48 minus the square root of 304, which gives me 30.56, and then I'm going to divide it by 2, which is $15.28. So the least amount you can charge is the smaller of the two, which is $15.28. In problem 2, what's the least amount you can charge for each CD to make a $100 profit? So we'll do the same thing, only we'll put a 100 on the left side. We'll bring everything to the left once again. Oops, that's minus. So 100 plus 300 would be 400. So my A is 1, my B is negative 48, and my C is 400. So negative 48 is 48. 48 squared again is 2304. Minus 4 times 1 times 400, all over 2 times 1. So 2304 minus 1600, get 704. Again, we're going to go to decimals, so let's go to our calculators. One of the answers is going to be 48 plus the square root of 704 over 2. Do not just go 2 into the 48 and then add the square root. It doesn't work that way. And the other one would be a minus inside. So my answers are 48 plus the square root of 704 is 74.53. I'm going to divide it by 2. So I get $37.27. My other answer, 48 minus the square root of 704, is 21.47. I'm going to divide that by 2. So 10.73. And again, they're looking for the least amount you can charge. So I'm going to circle the smaller answer, which is $10.73. If you do that all at once, you get 1074. If you get 1073. If you just simplify the top part into 2 decimal places, then I believe it gives you what the book says, which is 1074. And the same on that last one. They were 1 cent off. The next part talks about the discriminant, and the discriminant is this part right here. It's the part that's under the square root, and that's the part that determines how many answers that you have. Your choices are going to be 2 real, 1 real, or no real. And here's how that breaks down. The number of solutions can be 2 reals if the discriminant is bigger than 0. So if it's positive, you're going to get 2 real answers. You get 1 real if the discriminant equals 0, and we did a couple of those already today. We have 1 x-intercept in that case. There's no reals if that part underneath the square root, which is the discriminant, is negative, which makes sense because we can't have negative square roots. And there it wouldn't cross the x-axis at all. So for these, they're really pretty easy. You just have to look at what you get at the end. Check to make sure everything is in the right order, which it is. My A is -2, my B is -3, and my C is 5. The only part I have to do is the b squared minus 4ac part. You don't have to plug it into the whole thing because all they're asking for is the number of real solutions that you have. So b squared would be -3 times -3, which is 9, minus 4 times -2 times 5. So 9 plus 40, which is bigger than 0. So we have 2 real solutions on this one. So really the part that I want you to show is at the end, what is that discriminant equal to? Is it equal to 0, greater than 0, or less than 0? So let's look at another one. Everything's in the right order. My A is 2, my B is -3, and my C is 7. Again, we only have to do the b squared minus 4ac part because we're only looking at the number of the real solutions that we need. -3 times -3 is 9, minus 4 times A, which is 2, times C. So 8 times 7, 9 minus 56. That's going to be a negative number. And that is less than 0. So in this one, we have no real solutions, sorry. And that makes sense because under the square root, you can't do square roots of negative numbers. For this one, they are not all on the same side, so let's get them there. Decide what our A is, 1, B is negative 6, C is negative 5. So B squared minus 4AC once again would be negative 6 times negative 6, which is 36, minus 4 times 1 times negative 5. This is going to be a plus 20, and we get 56, which is greater than 0. So 2 real solutions. So basically, if you go back up to that chart and refer back to it, you're going to get your 2 real solutions. Problem 4 is another application question. You hit a golf ball into the air from a height of 1 inch above the ground with an initial vertical velocity of 85 feet per second. The function models the height in feet of the ball at time t in seconds. Will the ball reach a height of 115 feet? Well, we need to figure out where to put that 115. It's going to go in for your h. So it looks like this. We will get everything on the same side, and since the t t squared is negative on the right, let's bring everything to the left. So 115 minus 1/12 is 1379 over 12. Weird number, but that's what it is. Then we look to calculating how many answers that we need to have. So again, on this one, they're just asking for will it reach that height? So we're going to indicate the b squared minus 4ac part. So b squared would be a negative 85 times a negative 85, which is 7225, minus 4 times 16 times 1379 over 12. I'm just going to type that in. And I get a negative 129.67. As you know, when we look at the b squared minus 4ac part, if it is less than 0, there are no real answers. So our answers will be no, the ball will not reach 115 feet. For word problems, you always kind of have to put it into that perspective and answer the question in that way. Without solving an equation, will the golf ball in number 4 reach a height of 110 feet? So again, we have to start out by plugging the 110 in, setting it equal to the function they gave. And getting everything on the left side. So 110 minus 1/12 is 1319 over 12. You could probably put this in decimal form since we don't have to solve anyway. Again, b squared minus 4ac to see if they have some answers. Negative 85 squared, 7225, minus 4 times 16 times, it's like 109.9. I'm going to subtract them. And we get 190.33. For this one, since it is positive or greater than 0, the answer will be yes. There are 2 real solutions. So that would mean that the golf ball would reach the height of 110. And that's it.